So next we are going to see about the VLSI. Actually, this is not an instrumentation field, but actually when you are doing instrumentation and electronics and instrumentation, you guys can opt this VLSI, very large scale integration. Is a chip fabrication, IC chip integrated circuits fabrication. So mainly the electrical and electronics engineers, electronics and instrumentation engineers, instrumentation control, and then electronics and communication engineers. So electronic engineers can opt this VLSI systems. Even mechanical engineers actually, what they are doing chip fabrication and manufacturing, high tech industry where VLS this E&I, ECE, and Triple E guys can do VLSI programming, so chip programming, so-called chip programming. And then what are the courses of study here, right? Actually, so to become a VLSI guy, actually, so you need to know the crystal growth, epidoxy and oxidation, crystal growth and wafer preparation, vapor phase epidoxy, molecular beam epidoxy, silicon on insulators, epidoxal evaluation, oxidation techniques, and systems, oxide properties, oxidation of polysilicon, and then we have lithography, optical lithography, electron lithography, X-ray lithography, ion lithography, and then reactive plasma etching techniques and equipments, and specific etch process, dielectric and polysilicon film deposition, plasma assisted deposition, and then we have diffusion, right? First we discussed about the crystal growth and everything, then lithography we have, then as a third thing diffusion models. So diffusion, so in these models of diffusion of in solids, diffusivity measurement techniques, diffusion of silicon dioxide, ion implementation, implantation equipments, annealing, shallow junction, high energy implantation, metallization, and then choices, physical vapor deposition, patterning, metallization problems. So this forms a diffusion study of field, and then process simulation and integration. So the process simulation, ion implementation, diffusion and oxidation, epidoxy, lithography, etching and deposition, process integration, NMAS, IC technology, MAS, CMAS memories, bipolar ICs, and BIC mask fabrications. So this is about the process stage for IC fabrication. And then actually analytical techniques, so packaging and reliability, analytical techniques, analytical instruments, electron beam instruments, scanning electron microscopes, ion beam techniques, chemical methods, packaging design coordination, VLSI assembly techniques, so which includes packaging of fabrication technologies, reliability instrument requirements for VLSI, so to measure yield loss in VLSI failure mechanism, design automation. So this electron microscope scanning and everything which is used for measuring the vapors formed and deposits formed, to measure whether the IC chip has been fabricated correctly, the deposits have been maintained properly, temperature is maintained, pressure is properly maintained. So the ion beam techniques, which is the chemical methods for packaging and design considerations to measure the accuracy of VLSI fabricated chips and everything. So when you need to read about text related to VLSI, if you want to know about textbooks, we have ECE VLSI technology by Tata McGraw Hill Limited, then Patnaik VLSI system design Tata McGraw Hill Limited, and then Dialinger VLSI engineering Prentice Hall of India Limited. So these are the textbooks recommended. And if you want to know more about the VLSI, we have references, that is Elian Integrated Circuit Fabrication Technology, McGraw Hill Limited, and Kunkal Basic VLSI Design Systems and Circuits, Prentice Hall of India, and Dio Giacomo VLSI Handbook, McGraw Hill Limited. So these talks about the very large scale integration, chip fabrications, which is suitable for electronics and instrumentation, electronics, electrical, and then actually the communication kind of engineers. And see this chip fabrication also, the mechanical engineers or I mean those metallurgy engineers actually can get a job. So, but actually they need to do higher studies in overseas, right? So even actually one of my friend actually did. I mean, he's basically a metallurgy engineer from I mean now it is called NIT Trichy. Earlier it was a regional engineering college Trichy. So he did metallurgy there, and then actually he went for higher studies in USA in the field of metallurgy, and then actually he turned his career in VLSI, and now he became a chip manufacturing design engineer in California. So this is very good, but actually again actually day by day actually the technology is going old and become saturated at one point of time. So now actually we have many VLSI engineers in this field, but actually the number one reaching the number one is in your hands, right? So I hope the details have given actually the chip fabrication technology related things. So this makes the world actually say very small. Earlier actually we have big, I can say the big actually room kind of equipments like say in IBM, even IBM central computer system is a big complex kind of thing. And then we have vacuum tubes, diodes, vacuum tubes, and say transistors and everything, which are replaced by integrated circuit technology. And this integrated circuit technology uses this VLSI technology for fabrication, as well as we have VLSI programming experts required in the field. So it makes a huge world into small handled or pocket sized kind of electronic automation equipments, where cell phones are designed. Big communication equipments can be olden days Bell equipments or very big room size kind of thing. So you can see in if you want to see in India, actually you can go to Visvesvaraya Institute of Science Studies actually in Bangalore. You can see a room kind of thing actually, so recorders and transmitters and all this actually this automation systems can be operated mechanically in a huge room kind of thing. But now everything will be in handheld pocket-sized devices. Now we have microelectronics now converting to nano electronics. So in olden days we can still in coming future it will even actually will be very powerful nano to the some X powers actually the size equipments will be coming. So I hope actually this is a good chance for the young people to learn a lot of things in the new engineering trends. So get it done and get a scope of and also get a good placement in the job industry. Thanks, friends. Shivakkumar again.